All right, now let's change focus a little bit and let's talk about qualitative versus quantitative variables. Okay, first of all, what is a variable? I know you're familiar with variables from algebra, but we use the word a little differently in algebra than we do in statistics. In algebra, usually when we say variable, what we mean is something that's unknown. In statistics, when we say variable, we mean a characteristic that can change or vary from individual to individual. Like we said a while ago, hair color is a variable because it changes from person to person. Height is a variable because it changes from person to person. Okay, so variables come in two basic types. A variable can be qualitative, meaning it's a categorical variable that allows for classification of individuals based on some attribute, or it can be quantitative. In other words, it can provide numerical measures of individuals. The values of a quantitative variable can be added or subtracted and provide meaningful results. For example, height and age. You can add two heights together, or you can subtract two heights to compare them. You can subtract two ages to compare them. You could not add or subtract two eye colors. So you see the difference? Usually qualitative is some kind of categorical data. Quantitative is numerical. But now keep in mind that not all numbers are automatically quantitative. For example, can you subtract two phone numbers and find out anything useful? And the answer is no. So numbers that are meant to label, such as zip codes and phone numbers, those are not quantitative data, those are qualitative. Even though they are numbers, adding and subtracting them has no meaning. So quantitative variables means numbers that we can add and subtract and compare and have meaningful information. As an example, let's consider a few different variables and decide if they are qualitative or quantitative. Okay, first up, gender. So like male or female. That's obviously not numeric, so it's going to be qualitative. What about temperature? Well, temperature is definitely measured in numbers. So now the question is, does subtracting give us any useful information? Yes, I can subtract today's temperature from yesterday's temperature and find out how much warmer or cooler it is. And so temperature is going to be a quantitative variable. All right, number of days during the past week that a college student studied, that is quantitative as well. Because I can say Joe studied 3 days and Jim studied 5 days, therefore Jim studied 2 days more than Joe. Okay, what about zip code? Zip code is numbers, but the numbers don't have any meaning beyond just being a label. So although it's numbers, a zip code is qualitative data. Okay, now let's talk about distinguishing discrete variables from continuous variables. Okay, now quantitative variables come in two types, discrete and continuous. So a discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. The term countable means the values result from counting, such as 0, 1, 2, 3, and so on. A discrete variable cannot take on every possible value between any two possible values. For example, think about counting the number of eggs a hen lays. A hen can lay 1 egg or 2 eggs or 3 eggs, but she can't lay 2.5 eggs. So it's not possible to have that value in between 2 and 3. So this is discrete. Discrete here meaning that we hop from one value to the next. On the other hand, a continuous variable is a quantitative variable that has an infinite number of possible values. So a continuous variable can take on every possible value between any two values and can be measured to any desired level of accuracy. Think about measuring the amount of milk a cow gives. Okay, so here's where we are. we have two different kinds of variables. We have qualitative and quantitative. Quantitative variables can be divided into two kinds, either discrete, things that we count, 1, 2, 3, 4, or continuous, things that we measure. Okay, now let's look at these quantitative variables and decide if they are discrete or continuous. So first up, the number of heads obtained after flipping a coin 5 times. Well, the question is, would you count the number of heads obtained or would you measure it? Well, you would count either 1 or 2 or 3 or 4 or 5 heads come up when you flip the coin. So that's going to be discrete. All right, next up, the number of cars that arrive at a McDonald's drive-thru between 12 and 1. Okay, the number of cars is going to be a whole number. Either 1 car comes through or 2 cars or 3 cars, and it's not possible for us to have 2.5 cars. So these numbers are hopping from one value to the next, and this is also discrete. And then we have the distance a 2010 Toyota Prius can travel in city driving conditions with a full tank of gas. Okay, distance is not counted, distance is measured, and so this is going to be continuous. It is definitely possible for a Toyota Prius to drive 20 miles or 25 miles or any number in between, 22.3 miles or 24.721 miles, and we can have any number of decimal places that the odometer will give us. And so we're measuring, not counting, and so this is continuous. Okay, here we have a table, and in the table we have all these different countries, and for each country is listed its government type and the life expectancy of the population of that country and the number of people that live in that country in millions. Okay, so who are the individuals? Remember, the individuals are the people or objects of interest, and so the individuals here are Australia, Canada, France, Morocco, Poland, Sri Lanka, and the United States. In other words, all the countries. The individuals are the countries. The variables are the things that we are finding out about the countries. So in this case, government type, life expectancy, and population. And the data are all the things that you see in green here. So the data are the observations for each variable. Now let's switch gears just a little bit and talk about the level of measurement of a variable. Okay, rather than classify a variable as qualitative or quantitative, we can assign a level of measurement to the variable. And there are 4 levels, and we're going to talk about each one individually, and then we'll practice. So first off, the nominal level is the lowest level. At the nominal level, the values of the variable either name or label or categorize, and really nothing more. For example, the naming scheme does not allow for the values of the variable to be arranged in a ranked or specific order. So some examples of data at the nominal level would be name, town, state, zip code, or phone number. You can put names in order, but that doesn't tell you anything about the people. Putting the names in alphabetical order doesn't mean that the people have been put in any kind of meaningful order. Putting zip codes in order doesn't tell you anything about the areas of the country that match up with those zip codes. So all nominal level data can do is really just label things for you. Now at the ordinal level, we have all the properties of the nominal level, plus we now have the ability to arrange things in a ranked or specific order. So anytime you have, say, for example, first place, second place, third place, those are in order. Presumably first place is better than second, and second is better than third. How about the Olympics? Gold, silver, bronze. How about Amazon's rating system? 5 stars, 4 stars, and so on down to 1 star. Now think about it. Although we can put these things in order, the difference between first and second place and then second to third place is not constant. Think about the Olympics. I remember several years ago watching Michael Phelps. He squeaked out a gold medal, and the difference between gold and silver was only, say, a few thousandths of a second, but the difference between silver and bronze was several tenths of a second. And so we see that the difference between gold and silver is not necessarily the same as the difference between silver and bronze. There may be very little difference between a 5-star and a 4-star rating, but a lot bigger difference between a 2-star and a 1-star rating. So just to subtract the stars doesn't really tell you anything about the difference. So now let's step up from ordinal data to interval data. At the interval level, we have all the properties of the ordinal level, meaning we can put things in order, plus the differences in the values of the variable have meaning. So we're a step above ordinal. However, we're limited because a value of 0 does not necessarily mean the absence of the quantity. We can do things like addition and subtraction, but we can't divide, like we can't say this is twice as much as that. All right, so what kind of data can you think of that 0 doesn't mean 0? Well, there are only a couple. Years AD or years BC come to mind. Also temperature. Year 0 wasn't the beginning of time, and a temperature of 0 degrees doesn't mean that there's no heat. In other words, we have years BC before year 0 AD, and we can have negative temperatures. So 0 doesn't really mean none. Now you can subtract two temperatures and say it's 3 degrees cooler today or it's 5 degrees warmer today, but you can't divide them and say it's twice as warm outside. For example, if today, suppose it's a really cold winter day and it's only 1 degree outside, and tomorrow it's 2 degrees. Is the 2 degree day twice as warm as the 1 degree day? It doesn't make any sense to do it that way. So at the interval level, we're at this weird place where we can add and subtract, but we can't divide. We can't say twice as much or half as much or anything like that. And it only occurs with years AD and BC or with temperature. Now, most of our numerical data is actually at the ratio level. At the ratio level, we have all the properties of the interval level, plus we have ratios of the values now have meaning. And a value of 0 really does mean an absence of whatever we're measuring. Arithmetic operations such as multiplication and division can be performed on the values of the variable. Really, this includes all of our numerical data except, as we said on the interval level, temperatures and years. For example, some data that would fall in the ratio level would be age, height, weight, number of pets, number of square feet, inches of rainfall, just about any number you can think of, just not temperature and not years AD or years BC. Okay, so how does this compare to what we learned about qualitative and quantitative variables? Well, nominal and ordinal levels are qualitative. They might be numbers, but the numbers are meaningless, meaning that all they do is label. So that's going to be qualitative. And then interval and ratio levels are quantitative. They are numbers, and the numbers have meaning. So now remember that interval level data can have a value of 0 that doesn't mean none. The only two examples of interval data that we usually come across are years, like year 0 was not the beginning of time, and temperature, like 0 degrees does not mean the absence of all heat. And when I say years, I mean years AD and years BC, like 1987 and 2005. We don't mean years of age, like 3 years old, 5 years old. That would be ratio level. But when we're talking about years AD or years BC, then that's interval level data. And those are really the only two examples that we will typically see of interval level data. Otherwise, if it's numbers and it's not one of these two things, it's ratio level for us. Okay, here's an example for us. We're going to take each of these variables and classify them with a level of measurement. Okay, so first up is gender. And examples of gender would be male, female. So that is definitely qualitative data. And so the question becomes, is that nominal level or is that ordinal level? Well, when you say that one person is male and another person is female, have you put them in any kind of order? Obviously not. So the gender is going to be just nominal. In other words, all that does is label the person. Okay, temperature. Well, temperature is numeric, so we're either talking interval or ratio. But remember, the difference between those two is that with interval data, 0 doesn't mean none, and certainly a temperature of 0 doesn't mean 0 heat. So we know that because we can have negative temperatures. So remember, temperature is one of our interval level things, and there were only two, remember? Temperature and years AD or years BC. Those are the only interval level data that we have. Okay, number of days during the past week that a college student studied. Well, 0 means 0. 0 means he didn't study at all or she didn't study at all. So this is definitely ratio data. And then letter grade earned in your statistics class. Well, the letter grades certainly can be put in order. A grade of A is better than a grade of B, which is better than a C, and so on. But we can't subtract them because they're not numeric. So I'm going to say that's ordinal. And I think if you practice with these a little bit, these are actually very easy to do, although they do throw some people for a loop at first. But you just have to practice them and think about them. And so I hope you'll do that. Get in MyLabs Plus now that you have finished this first section of notes. Open up MyLabs Plus and work some problems and answer some questions. And the more you think about it and talk about it maybe and write it and read it, the better, of course, it sticks with you. And one thing I want you to remember throughout the course is that learning takes time. You're never going to be able to sit down at 8 o'clock on Sunday night and do your best before the deadline at midnight. Ideally, you should be working on statistics a little bit every day or every other day. And you need to plan it that way. You need to plan it where you do a little learning, you do a little homework. Then you do a little more learning, you do a little more homework, and then you take your quiz. And that's how it's going to go all semester. And just remember that your instructor is there to help you. You can send them Ask My Instructor questions in MyLabs Plus. You always need to go through the notes and the videos first, and then do the homework, and ask us questions because we want to help you succeed, and we are here to help you. So find us in Canvas, find us by email, find us by sending Ask My Instructor questions through MyLabs Plus. But, definitely always reach out if we can help you. Good luck with the course.